We're going to continue talking about continuity and one-sided limits. First problem we're going to look at is one that says find the constants, in this case of just a, such that the function is continuous on the entire real line. So what we'd have to do is we would look at this, and we know that sine is continuous everywhere because it's just the periodic function that goes up and down, up and down. The one thing that makes us discontinuous is this x down here. But if you look here, it says when x is less than 0, so that would exclude that one bad point. The next part, when you plug in here, this is a line, so I know it's continuous everywhere. So really we just need to see if these two connect with one another. So what we're going to do is we're going to check the limit from the right and from the left. So I'm going to check the limit as x approaches 0 from the right, and the limit as x approaches 0 from the left. From the right would be this line here, a minus 2x. Using the substitution method, we just plug that in, and we find that we get a minus 0, which is a. The limit as x approaches 0 from the left is this first function, 4 sine x over x. And what I end up getting is bringing this 4 out front. So I've got 4, the limit as x approaches 0 from the left of sine x over x. And if you remember, we're supposed to memorize this to be a 1. So we have 4 times 1, which is 4. So that means we would want a to be equal to 4 for this piecewise function to be continuous on the entire field. The next problem we're going to look at says discuss the continuity of the composite function. And so here's my f of x and here's my g of x. It says to find f of g of x. So g of x is x minus 1. And then when I plug that in for the x portion, I get 1 over the square root of x minus 1. This function right here, what we're looking at is we know we can't have zeros on the bottom of the fraction, which would be at 1. So 1 is not going to work as part of this domain. Also, we've got square roots, which we can't have negatives underneath the square root. So if we think about what numbers will work, numbers to the right of 1 like 2 are good, but numbers to the left of 1 like 0 are not going to work. So the continuity of this is that x has to be greater than 1. Another way we can write this is an interval notation, which would be 1 comma to infinity. Notice I've used parentheses. Parentheses means a greater than sign, so 1 is not included in it. Either one of these answers is correct, but it's continuous when x is greater than 1, or you could write the interval notation 1 to infinity. On this next part, we were supposed to use a graphing calculator to find any x values for which the function is not continuous. Well, what I know about this is that the only value that would be on this part where it would not be continuous is if x was equal to 0. And this is a line, so I really just need to see if these match up, just like I did in the very first problem of this video. So I'm going to check the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right. And I just need to make sure that f of 0 exists, and it is the same number. F of 0 is 0. It would fall underneath this function right here. From the left would be the top function, so cosine x minus 1 over x. This is one we are supposed to memorize, so this limit is equal to 0. And the other one is 5x. So by substitution method, I have 5 times 0, which is 0. So since all three of these are equal to 0, there are no values at which it's continuous. Therefore, it's continuous on all x. We're going to take a break. Alright, for our next problem, we're going to continue talking about continuity, and all we're supposed to do is describe the interval in which the function is continuous. So you can describe this one of two ways. You can use notation that you guys are familiar with, where you say that x starts at -3 and goes on forever, so you can say x is greater than or equal to -3. Or what you guys need to get more used to is seeing the interval notation, which is it starts at -3, so -3 is included because it's a colored in dot, and then everything to infinity. Either answer is correct. This is the way we want to start writing our answers, so it's an interval notation. Alright, and the next problem, it says, does the graph appear to be continuous from -4 to 4? Now, you would be using your graphing calculator to do that. I'm just going to talk about it. You guys should put it in your graphing calculator, and this is something we can discuss further in class. When you put this in your graphing calculator, you're just supposed to look at it and say, yeah, it looks like it's continuous everywhere. So, that's what I would write. It appears to be continuous from -4 to 4. However, if you look at it a little bit further, we know it can't be continuous everywhere because at 2, there is a discontinuity, there's a hole. So, we need to write that. So, however, there is a hole at x equals 2 when looking at the function analytically. Okay, one of the theorems that we're going to see this year is called the intermediate value theorem. And so I'm going to mark the important parts of this. The first thing is that f is continuous on the closed interval. So f is continuous on the closed interval. You can see that there's no holes or gaps or anything. It's just continuous from A to B. And there, it says then there's any number, and k is any number between f of A and f of B. Now remember, f of A and f of B are your y values. So here's f of A over here, and here's f of B. Let me fix that up just a little bit. So that k, there's a k that's between f of A and f of B. Now, if you draw over to however this is connected, that what they're saying is that there's some number c that falls in between A and B. So we've got to have a continuous function. We can then say that there's some number between those two heights. And so therefore there's a number, that number c that goes along with k is between A and B. We use this more specifically to show that something has a zero or a root. So let's go ahead and look at this next question. It says explain why the function has a zero in the specified interval. So what we're going to do is look at what f of A would be, which would be f of 0, and look at what f of B is, which would be f of 1. F of 0 would be 0 cubed plus 5 times 0 minus 3, and f of 1 would be 1 cubed plus 5 times 1 minus 3. So f of 0 is going to be negative 3, and f of 1 would be 1 plus 5 minus 3, which is 3. So how do I know this has a 0? It is because of the intermediate value theorem. So we'll say that by intermediate value theorem, since f of x is continuous, we know it's continuous because it's a polynomial, and f of 0 equals negative 3, and f of 1 equals 3, so f of a is equal to some negative 3, and f of b is equal to 3, then for at least one number c between 0 and 1, f of c equals 0. So what it's saying is, since this is at a height of negative 3 and this is a height of 3, at some point it has to pass through 0 to get to that 3. On the next problem, but we're going to take a break at this point, is we're going to actually find that 0 that we're talking about in this problem. Okay, in this particular problem, we're asked to use a graphing calculator to approximate the 0 of the function. What I want you guys to do is try this on your own. Each calculator is different, so we will more than likely need to be discussing this during class, but you should be able to approximate it by hitting the trace button on your own. You should find that the approximate 0 is 0.5961. I will definitely cover that during class. We need to talk about graphing calculators and making sure that we know how to find those zeros. Zeros where it crosses the x-axis. The x-intercept is another name for it. So our last problem we're going to look at is we're going to verify that the intermediate value theorem applies to the indicated interval. And we're going to find the value of c guaranteed by the theorem. So the way we're going to do that is we're going to first state that we have a continuous function because we have to have continuous in order for IVT to apply. So f of x is continuous on 0, 3. The next thing we need to do is we need to find the function height at each of the endpoints, so f of 0 and f of 3. F of 0 is 0 minus 0. We've got a typo here. Let's correct that. It looks like it's supposed to be plus. So let's go ahead and change that to a plus sign. 0 minus 0 plus 8, so that means it's 0. And then we have 3 squared minus 6 times 3 plus 8. So I end up getting 9 minus 18 plus 8, which is a negative 1. So f of x is continuous. And then I can go on here to say f of 0 equals 8 and f of 3 equals negative 1. Since negative 1 is less than 0, less than 8, IVT applies. So what I'm going to do is I'm going to find that guaranteed value. So where does the function equal 0? And we can do that just using some basic algebra. So I'm going to do x minus 2, x minus 4, and I get x is 2 and x is 4. However, x is 4 is not my answer because it's outside the interval. So x equals 2 is the one that is where the 0 takes place.